Hi, welcome back to my channel. In this video, I will show you how to control LEDs on an ESP32 via WhatsApp using Twilio Sandbox. In general, the concept works like this. From smartphone, we will send a command message, which is then received by the ESP32. The ESP32 will process the message, and control the LEDs accordingly. In other words, we'll be able to control the LEDs using WhatsApp. I'll be controlling 3 LEDs, red, yellow, and green. In detail, the smartphone sends a command message to the Twilio Sandbox number, which is then received by a Node-RED webhook. Node-RED forwards the message to an MQTT broker, and the ESP32, acting as an MQTT subscriber, receives the message and controls the LEDs accordingly. Besides acting as a subscriber, the ESP32 will also publish the status of all LEDs to the MQTT broker. Node-RED will then receive this status update and send it back to the sender on WhatsApp via the Twilio Sandbox API. This video is similar to my previous one, Control ESP8266 from WhatsApp using Node-RED and MQTT, but with a slightly different approach. In this video, I'm not using a physical ESP32 but instead simulating it with Wokwi. In the Wokwi simulation, I'm using an ESP32 as the controller, along with 3 LEDs, red, yellow, and green, and resistors. Here is the code. I'm using several libraries, mainly for handling MQTT messages. Don't forget to configure the Wi-Fi SSID and the MQTT broker you'll be using. This code will receive MQTT messages containing JSON to control the LEDs based on the color and status sent. If the received message is status, the ESP32 will send the current status of all LEDs to the MQTT broker. From there, Node-RED will read the status and forward it to WhatsApp via the Twilio Sandbox API. Here is the Node-RED flow code. To receive messages from the Twilio number, we use the HTTP in Node and set the URL as webhook. Next, we verify that the sender's number is registered. If the message is not status, it will be processed into a JSON format containing device and trigger, which will be sent to the MQTT broker to control the LED. Make sure the MQTT broker address is correct and that the topic matches the one set in the ESP code. If the received message is status, it will send a status request to the MQTT broker. Node-RED will receive the LED status message from ESP32 in JSON format. In the function node, the message will be processed to extract the status of each LED. After that, the process status will be sent back to the sender's WhatsApp number via Twilio Sandbox API. Make sure the MQTT broker address is correct and matches the one set in the ESP32 code. Also, ensure that the Twilio account SID and token are properly configured, and that the sender's WhatsApp number is registered in Twilio Sandbox. In the Twilio console, under the Send a WhatsApp message section, you will find the WhatsApp sandbox for using Twilio Sandbox. Make sure the sender has joined the sandbox by sending a message to the Twilio number. Then, in the sandbox settings, enter the Node-RED webhook URL that we have created. Now, let's run the simulation. In Wokwi, click Start Simulation and wait until the ESP32 successfully connects to the Wi-Fi and MQTT broker. Once connected, ESP32 will start listening for incoming MQTT messages and will be ready to control the LEDs based on the commands sent from WhatsApp. I will send the message all on to the Twilio Sandbox number. Then, we will see the MQTT message being received by the ESP32, and all LEDs will turn on. Next, I will send the message all off. Then, we will see that all LEDs will turn off. If you want to turn on only one LED, for example, the red LED, the command is red on. This will turn on only the red LED while the others remain unchanged. The same applies to the yellow and green LEDs, just replace red with the desired LED color in the command. When I send the command message status, the ESP will read the current status of each LED and send back the information for each one. In this video, we started by explaining the overall concept, sending a command from WhatsApp, processing it in Node-RED via a webhook, forwarding it to an MQTT broker, and having the ESP32 respond accordingly by turning LEDs on or off. We also learned how the ESP32 not only acts as a subscriber to control the LEDs, but also as a publisher that sends the LED status back to the MQTT broker. From there, Node-RED reads the status message, processes it, and sends a reply to the original sender via Twilio Sandbox API. This creates a two-way communication between WhatsApp and our ESP32 device, enabling both control and monitoring, just by using simple text messages. We also used Wokwi as a simulation platform, which allowed us to build and test the entire system virtually without any physical hardware. It's a great way to prototype IoT ideas quickly and safely. This project is a great example of how powerful and flexible IoT systems can be when you combine the right tools. With just Node-RED, Twilio, MQTT, and ESP32, even in simulation, you can build a reliable system that integrates messaging platforms with hardware control. Thank you so much for watching. If you found this video helpful, please give it a thumbs up, leave a comment if you have any questions or suggestions, and don't forget to subscribe for more IoT and automation tutorials. See you in the next one.